Hello guys, I'm Nitin here. You are watching Civil Struck Design. I hope you guys are doing absolutely fine. In this video, we will learn how to model a complete designing, modeling, and everything in the Etabs software. So I have this AutoCAD plan. If you want this, you can comment me. You can message me. Okay, so I have already made the center line of this plan here. So you can see this is the center line of this of that plan, and I will import this plan in the Etabs. So I will show you how to model, how to draw the beam column slab, and how to analyze the model and designing. After that, we will do the designing also of this model, and we will check the behavior of the structure after the analysis. Is it pass or not, and it is having any deflection or not, any displacement or not. Okay, so I have made the this center line of that plan. So I will import in the Etabs software. I will show you each and everything in front of you guys. I will do each and everything, and I will do model what I do and what I draw. I will clear each and everything in front of you guys. Okay, so first I close this. If you don't close it from the AutoCAD, then it will not open in the Etabs software. So I am closing it from here, and so I go to the Etabs software. So here I have come in the Etabs software. First I go to the file. You can see here the file toggle option. So go to the new model. Okay, so I hope you guys all have the GitHub software. So if you don't have, I have already made the video of that, how to download and how to install it in your PC. So first you have to go to the model initialization, and after that display unit you have to click here the metric assign it, and after that steel section database I am choosing here the Indian standard, and the steel design code I'm choosing here IS 800 2007. It's the Indian standard code, and the concrete design code I'm choosing here IS 456 2000. Okay, so you can select it from here. If you want to design your building with the ACI 318, it's American code, you can design it for American code also. So now I'm clicking here OK, and after that I don't want to make any grid. Okay, so I want to import the plan form of the AutoCAD file, the DXF file. So I'm clicking here custom grid spacing. So number of stories are 4, and the typical story height is 3, and the bottom story height is also 3 meter. Okay, 3 meter, 3 meter. And it's a blank. You have to select here blank. You don't have to select the grid only. You have to select blank. Okay. So after that you have to click OK, and now this screen will pop up. It's a blank screen will pop up, and after that you have to go to the file toggle. You can see in the top left corner the file, and go to here import, and after that you can see here import. After that you have to go to the DXF file of floor plan. Okay, DXF file of floor plan, click OK, and now I want to import this drawing 7 file. Okay, open. After that you have to click open, and the DXF file unit I'm choosing here in and you have to select this center line here, and I don't want to import the column because I will manually draw the column. Okay, so after that you have the global up direction should be in the Z direction. In the Etabs, the up direction, this is the X. You can see this is the X, this is the Y, and here will be the Z direction. This will be the, you can see in my cursor, this will be the Z direction. You can see in the 3D view, this is the X, this is the Y, and this is Z. You can see here in the 2D X, Y, and this is upper up direction is the Z direction. So that's why it is saying that global up direction is the Z direction. In the Stat Pro, you will see the global up direction is the Y direction. Okay. So after that, you have to go to the DXO file unit here in the and the beam properties. I will assign the beam properties after after the importing this file. So story level plan location, I will first you have to select the story level. So I will select here story 1. I want this I want this imported file at the story level 1. Click here OK. Now it will show you um, to save the model. So I am selecting here model 2. Okay, so click OK. You can see here the model has been imported, so it is not showing here. Do you know why? Because we are at the story 4. Okay, so first we have to go to the story 1, then we can see our model plan. And you can see here this the plan has been imported, and you can see this is the whole one beam here. So first I want to first you have to intersect it, select all these and go to the edit frames, divide frames, break at intersect with selected frame and joints. Okay, click here apply. You can see here it has been intersected in the one. Okay, so you can see intersected. Very good. So it is not showing the long beam. Okay, so after click here OK. Now I have to define the member properties and go to define material properties. Sorry, material properties. First I have to define the material properties and go to here add new material. Here reason I am selecting here India, and the material type here is the concrete. I am choosing here M25 grade of the concrete. Unit weight you can see here 25. Click OK and add new material of the rebar. Rebar, you don't have to select here steel. Okay, so when you are going for the design of the steel structure, you have to select the steel. If you are designing the building, and here you have to select the rebar, and select here as YST grade. I am choosing here as YST grade 500. Okay, so click and you can see the unit weight of the 77 kilonewton per meter square. Click here, okay. After that, you have to go to the section properties, frame sections, and here I was you can see here the define the section properties and frame sections. Okay, first you have to go to the add new properties. So click here on the concrete section. You can see here the rectangular the concrete section. So if you want to import the circular, you can select here circular. So I want here the square and the rectangular shape of the beam and the column. Okay, so property name, you first have to select property name. So I'm choosing here the column size. I want to take here 300 by 350. So 300 is the width of the column, and the 350 is the depth of the column. So material type, click here M25 grade of the concrete, and the depth I'm choosing here 350, and the width I'm choosing here 300. Okay, so I'm not choosing in here the property modifier because there's so many people are learner here, so they are fresher, so it's very difficult to get to know them what is property modifier and where to use, when to use. Okay, so first you have to go to the reinforcement and modify show rebar here, and first click here the design type here column. Okay, column, and longitudinal bar I'm choosing here as YST 500, and the confinement bar is the stirrups, the confinement bar. Okay, like so as YST 500, and click here enforcement to be designed. I don't want to check, I want to design this. Okay, click here OK and OK. So I don't want these extra properties here, so uh, so click here these and OK, because this property has been assigned over there, concrete beam has been assigned over there when I imported that has been assigned. Okay, so what is the property size? You can see, go to define section properties. You can see what is the size of this default where is my column size, column property that I define. I have to define again it. So go to the concrete, and after that column 300 by 350 mm M25 grade of the concrete material type. You have to select here M25 grade of the concrete 350 by 300, and the reinforcement you have to select yeah, HYST 500, HYST 500. Clear cover will be 40 mm. So click OK and OK. After that you have to delete these unnecessary files which have not been used, and the concrete beam size here is 500 by 375. So I want to modify it, I want to edit it. So click here beam size, I'm choosing here 230 by 350. Okay, 230 by 350 I want here the beam size. So depth is 350 and the 230 is the width of the beam. After that you have to go to the reinforcement, and first you have to click here the design type is the beam. Design type you have to select here beam, the M3 beam. Okay, so click here longitudinal bar is the HYST 500 and the confinement bar is the HYST 500. So the clear cover, do you know what is the clear cover we use for the beam? So comment down below if you know. Okay, so you can comment on whether I am selecting I am typing here right or wrong. Okay, so I am choosing here 35. You can comment down whether I am wrong and I am right or wrong. 35 is the click cover is right and wrong. You can comment down below. Okay, so after that you have to click OK and click here OK. So column size I'm choosing here 300 by 350, and the beam size I'm choosing here 230 by 350. Okay, so after that click OK. You can select the beam size, has it been assigned or not. So you can see section properties, you can see here in the beam properties to 230 by 350. You can see here it has automatically assigned because we have changed the property from there, modified that property from there. Okay, so after that click OK. Now I want to draw the column here. So first select the column, and the first don't use these options from here. You go to the draw and draw beams column brace object, click here the column. Okay, so now you can go to the plan model, and you whether you can see where are the columns. Okay, so you can select it from here. So go to this and click here the show window stacked, and after that you can stack your window. Okay, so you can stack your window, then after you can see where are your column. And okay, so I don't want the 3D view of this, I want only 2D view. And you can see here. Okay, so you can see here. So I don't want to see this option here, so I'm clicking. And here are the my first column here. So you have to click on the joints. Okay, joints. This is my first column, and the next column is there. You have to click here in the joints, and the third one is there. Okay, so in the second row, first one is here in the staircase, the second one is here. So I'll have to change the orientation of this column. We will do after that. There and here and here also. We will change the orientation after. I'm drawing this. Okay, so here is another column, here also a column, here, and here also a column, and here also a column. Okay, so all the column I have drawn it, and you can see in the 3D view, you can see here in the 3D view all the column has been drawn. Now I want to change the orientation of the column, so go to the story first, and so this column is the horizontal. Yeah, you can see horizontal. Yeah, this in this column orientation I have to change, so go to select this column first. Okay, it has been selected. Now go to the assign frame, and here is option local axis, and I want to rotate in the 90-degree. So yeah, you can see it has been rotated. Okay, so another column I have to yeah, this one, this one, and this one. Yeah, I am selected in the multiple. I am selecting the multiple column here. So this one is also orientation is different. Here this one is also, here also. Yeah. So go to the assign and frame local axis, click here, and yeah, you can see all the column rotation I have changed it. Okay. So now next task is our this is our plinth level. So now I want to I want to change the story data here. So go to the modify story here, and the story first one is the ground level, and yeah, first this is our plinth level. Yeah, plinth level, ground level, first, second, and I want to add the next story. Two, and this is our roof. Headroom, you can say it, headroom also. I'm selecting here roof. Okay, so refresh it and click OK. Refresh it and OK. So I am not able to see this because we are in the roof. So go to the plinth level. This is our plinth level, and so I'm closing this Autodesk file. Okay. So I want to add the new window here because I want to see uh, the 3D view also. And after that, uh, next task is to replicate this floor because I don't want a floor here in the plinth level. Okay, so I want to replicate this in the second the ground floor. Okay, so go to the first select all the objects here, and then go to the edit and replicate story ground floor. So click OK. You can see we are in the ground floor. You can see here in the 3D view, and I want to go to the next floor here. Okay, so here I want a staircase here and here. So there in this side there will be a staircase for the ground floor only. There will be staircase only for the ground floor. In the architectural view you can see here, yeah, for the uh, for the ground floor here is the staircase. For the first floor and the second floor there is no staircase. Okay, so yeah, go to the Etabs model, and I want to draw a staircase here. So first clear it off. First I want to clear it from here and go to here, all stories, and select this part only, and click here the show selected object only. And so I want here a staircase. So at this level I want a staircase, so it will be uh, the staircase here. Okay, so first you have to this will be a 3 flight staircase. So I first you have to divide these beams in the 3 parts. So click here, edit frames, divide into 3 parts. Click here OK, and it has been divided in the 3 parts. Okay, so I want here this you have to select, first have to select the one story, and I want the first flight will come here in the middle of this, and then it will come here. Okay, so again I have to divide this column also in the 3 parts. So go to the edit frames and divide frames. I want this column, I want to draw this divide this column in the 3 part. This column I also want to divide in the 3 parts. Okay, so now we can make this flight here. So this is our first flight here. Now you can see this, and this come here, and after that it will go there, and then it will go there. Okay, so first you have to make the slab here, the landing slab. Okay, so I want the landing slab, but you have to, first you have to check the what is the length of this, what is the length of that uh, ground level, what is the length of this beam. 3 meter. Okay, 3 meter is the length of this beam. So I want to 1.2 meter, each part is 1.2 meter. Okay, so you first you have to make this landing slab of the 1.2 by 1.2 meter. Okay, so select this joint here and go to the draw and draw joint objects, and here you have to see close this window here, and you can now you can easily see what is here. So select this and select this and click here, draw joint objects. I want in the y direction. So 1 2 double 2, because these are in the mm. You can see the value you have to put out here in the mm. So 1200 mm, and click here. Okay, so in the x direction also you have to click here in the 1200 mm and click this and this. Okay, so here you also have to click here the mm in the mm. So click here 0, and plan offset you have to click here in the minus 1200. Click, yeah, here and here. Now you can easily make the slab here. So go to the before that you have to define the slab properties. So go to define section properties, slab sections here. So I would don't want this blank properties, click, and I want to modify it. So this is the stair slab. I want the 200 mm of the thickness of this stair slab. So click here OK, and I want the slab thickness. So slab is the 125 thick. So click here 125 okay. So I want to draw a stair slab here. So click this point and this point and click this point and drag it to up to, and now I want to draw it manually. So click this point and after that this and this. Okay. So I want to draw here the landing slab also. That is not the landing slab note, not the ongoing slab. Okay. So click here, first joint, second joint, third joint, fourth joint. Okay. So you can see here the ongoing slab, the going slab. First, second, third, fourth. First, second, third, fourth. Okay, so you can see I have successfully modeled this the staircase. So I want to draw here the Z beam also, because how will it support? Where will be the support? There is a no support, so I want here the Z beam also. So click this beam icon here. So I want the beam size of this 230 by 350. Click this part and here. So connect it from here to there. So you can see I have successfully drawn this beam also. You can see here the this staircase will come only the ground floor. Okay. So I want here also the stair also, and in that part also I want the staircase. So select this part, first go to the all stories here and select this part. Here I want to draw a staircase. Next staircase will come here. So first select these these two this beam. First I have to select this beam and I want to break it in the two parts. So click here, divide in the two parts. Okay, and after that you have to divide this column also in the two parts also. First you have to click here one story, click these columns, and I want to draw in, I want to divide it in the two parts also. Okay, then you want here the beam. Okay, and now I want this beam in the minus I'm sorry, in the y direction. So click here the replicate and click here in the y direction 1.2 meter, apply. Okay, now you can easily draw the slab here. After that you have to break this beam also in the two parts, divide in the two parts. Okay, now you can easily make the staircase here. First, second, third, fourth. First, second, third, fourth. Okay, you can easily draw this, model this staircase. So go to show all object. You can see. Now I want to draw the slab in the ground floor. So go to the here the slab option, this quick draw slab, and I don't want the stair slab here. I want the slab 125 So 25 here. So select this, drag it to here. I want here the slab. I also want here the slab. Okay, so you can easily model the your your house plan and your building plan in the Etabs software. Okay, here is the staircase. So first go to this select object option and click here. Okay, now you can see we have successfully done this ground floor plan. Okay, so now I want to import this plan to our second and third floor. So before that, I want to apply the loads on the beams and the loads on the beams and the loads of the slab, also the floor finish load and the brick load. First, go to the define load patterns. Here are the dead load and the live load. First, I want here the SIDL superimpose dead load. Here the super dead load will come here. Add. Okay. So after that, I want here the 5-inch ball here. So first go to the calculator here and the 5-inch wall I want there. So what is the 125 mm wall there? So 0.125. So 5-inch into the floor height is and the is 3 meter. 3 meter minus the depth of the beam. So 2.7 into the the unit weight of the bricks. So 19 mm. The unit weight of the bricks is 6.4125. So first select all the beams where the brick wall will come. So I'm selecting the all the beams here. I think that all the beams will be having the brick wall on it. Okay, so select beams and go to assign and the frame load distributed load 6.4 SIDL and click here 6.4 apply. You can see here I have successfully applied the load here, the brick load, and now uh, I want here the dead load and the super dead load will come, the floor finish load and the live load will come over here. So for the this floor, this is the ground floor slab. Here will come the 1.5 kilonewton per meter square will come here, the floor finish load, and after that here will come I will assign the live load also. Okay. So select all the floor here and go to the assign shell load, uniform load, and click here SIDL. So it's a floor finish load 1.5 kilonewton per mm square. So that will be the floor finish load. And after that, please select this and go to the live load here. So I'm clicking here 2 kilonewton will come here, the live load. Apply. Okay. Now, after that, you have to apply the load on the staircase also. Click all the staircase on this side and that side also. Yeah. Now I want here the shell load. The SIDL will come here 1.5 kilonewton of floor finish and the live load will come here 3 kilonewton because there will be the much live load. The people huge amount of load will come here because of the people will move down, move up with the load of luggage. Okay, so apply. Okay, so now we have successfully applied the load on it. Now I want to replicate this floor up to the second floor. This was our ground floor, the first floor. Okay, first floor and the second floor also. Okay, so first you have to select these all things from here and can check it from this view. And I don't want these staircase to the first floor. So unselect this by clicking here and select this beam also, this Z beam also, and select this Z beam also. Okay, and unselect, you can unselect this joint also, uh, joint. Okay, before that, yeah, this is the best. This is the this way you have to select. Okay, before that you have to join these columns that I have breakdown, these columns. Go to here, edit frames, join frames. Okay, before that you have to do this work. Here also you have to do. These columns are divided in the two parts. These four columns here. Yeah, these are jointed, and go to edit joins. Okay, now you can easily import your, yeah, you can select it from the ground level. Go to the ground level, select all these, unselect these, and select this beam also, and select this beam. Okay, now you can easily replicate into the first floor and the second floor. Replicate it, and first and the second. Done. Now it is done. Yeah. Now it is done. Yeah. And I want this part, this headroom onto the roof. Okay. So first you have to edit the name here, roof, headroom, headroom of the staircase. So go to the topmost, second, and select this hole and replicate into the headroom. And you can see here I have successfully done this work. So delete these beams. Okay. So now I have to draw a slab over here also. So you can slab done. Now I want to apply a load over here also. So here the shell load, the live load will not come there. SIDL of the 1.5 kilonewton, and the live load will come here, half of that. First you have to select this, apply, done. Okay, so in the roof, you can see here the 2 kilonewton of live load. In the roof you can see 2 kilonewton, but in the IS 875 part 2, the in the roof level there will be the half of that live load that you have applied in the down stories. So select these and go to the assign and the shell load, and the 1 kilonewton replace to existing. And here I have to draw the slab here also, that part, the next also. Go to undo it. Yeah, you can see here I have successfully done. So and that part also I have to apply the load because it's a roof level. So go to assign shell load uniform 1 kilonewton, down here 2 kilonewton. Done. Now this loading part has been successfully done. Now you have to go for the load patterns here and provide the earthquake data. Click here EQX and click here the type is the seismic and auto lateral load is the first you have to select here the code in which country code you are following. So I am following here IS 1893 2002. So add new. Now the here the new amendment also has been come the 2016. So 2016 Etabs to 2016 version does not support that. So for that you have to go for the upper version of this Etabs software. So select API. So you have to modify this lateral load and select this X direction here. And I am living in the Delhi, so 0.24 here. Soil type is the 2 and the importance factor I am choosing here 1. Okay, and the time period I want to calculate it manually. So first go to the length level. So for calculating a time period, you go to the this I'm going to the AutoCAD this file, and after that go to this ground floor and select the dimension here. 13.5 in the X direction, in the Y direction it is 9.8 meter. 13.5 and 9.8 in the X direction is 13.5. So go to the calculator here, and by this way you can calculate the time period. So the formula of the time period in calculating the time period is 0.09 height divided by under root lx and the ly for the different uh, direction. Okay. So first you have to see what is the height of our this model. So go to modify and the 15-meter height of this our model. So go to the calculator here and 0.09 into height 15 meter and 1.35 and the under root of the lx was the 13.5. So 13.5 under root which comes 3.67. So 1.25, sorry, that was 13.8, 3.71, 3.71. Okay, 3.71 is the under root of the lx and the 0.09 divided by into 3.17, 0.42 in the x direction. So click here define and load pattern in the x direction, that was 0.4.42, and the user you have to go here user defined 0.42 in the x direction the time period. Okay, in the y direction I have to calculate it again. So 0.0915 yes, I think I done some mistake. 0.09 into I did divide into 15, 1.35 and 3.13, 3.13. Okay, 3.13. Okay, so 3.13 and divided by 3.13, which comes out 0.43. So go to next 0.43 in the equal y direction. So 0.43 in the y direction. The time period will be followed here. So I have not selected the direction. So click here in the x direction and the y direction. The you have to select here in the EQI for the EQI and load pattern. Okay, click OK. Okay. Okay. Now this part has been completed. Now you have to go to the mass source here. So you have to reduce the live load. Okay. So click modify it and click here and go to here. The dead load will come here, multiply 1, and the SIDL also will come 1, and the live load will be 0.25 as per IS 1893. 25% load up to the 3 kilonewton. After for more than 3 kilonewton, you have to take the live load. Reduction factor is 0.50% you have to reduce. Okay, so click OK. Ignore last edit. Okay, okay, you can modify it. You can see here. Yeah, we have it's not successfully done because I have not add here it add. Now you can see. Yeah, now you can see here I have added successfully here. So after that you have to go to the load combination. So click here load combination, and I want to auto load combination. I want to use auto load combination. Concrete frame design, click OK, and the automatically load combination will be selected over here. Okay, so now the next task is to go to the run analysis. So after that you have to go for the run analysis. Okay, so go to the run analysis here. So you can see it is analyzing, so it has been successfully analyzing. So maximum deflection you can see minus 0.43. So it's here the maximum deflection you can see minus 1.591 mm. So permissible deflection limit is 20 mm and the span by 250. So it is passing in the deflection unit. So it is passing, this building is passing in the deflection. Okay, so you can see here the, and you after that you can see here the load, forces, stress and diagram here. So select here the frame pi spindle links forces, and after that you can see here the moment 22 for the beams. Sorry, for the columns, for the moment 22 for the columns, moment 33 for the beams. Okay, so you can see here the maximum moment, maximum deflection is 7.28. So 7.2. So you can see here the maximum deflection. Okay, so shear force you can check for the beams also. Okay, I think it is passing. Yeah, it is passing. Okay, now you can check here the, you can check the story response plot here for the maximum story displacement you can check, and I want to check for that one, and I want to check here the story drift, maximum story drift for the earthquake. For the earthquake load you have to check the story drift, and the value should be 0.004. So it is not showing here. Yeah, maximum story displacement you can see the maximum story displacement is 44 mm. Okay, so that's a good for structure. So 44 mm is not much, and you can check the maximum story displacement by h by 500. Okay, you can check it from that option also. So after that, you have to go to the designing option here, concrete frame design, and view revise preference. You have to select the code here, IS 456-2000, and now go to the select design combination. So I have selected the all the design combination, and now go to here, start design, check, and in this by this way you can check your whether your structure is pass or fail. Yeah, some beams are failing. You can see here some beams are failing. You can you can see these in the end display information also. So rebar percentage you can check here. Sorry, longitudinal bar percentage you can check here. Longitudinal difference you can check by this also. Okay, so after that you have to go to the design and verify all member whether this 18 members are failing. So I want to modify that member, so select these members and go to unlock it, and after that go to the define and frame sections here. So I want to modify this beam properties uh, to the 350 by 300 here. So click OK, and the column properties I want to choose here um, 450 by 300. Okay, now go to the run analysis and then go for the design part. After that go to the design here and start design check, and here go to the designing here and go to the verify is it pass or not. Now 13 members are failing also here. So go to the again go to the unlock it this and define section properties, frame sections. So I want to modify it to the I'm choosing here 450 by 450 beam size I'm taking here, and the column size I'm taking here uh, column size I'm taking here 450 by 450, and the beam size I'm choosing 450 by 300. After that go to the analysis and go to the design, concrete frame design, and after that start design check. uh, like this way you can see the it is checking whether it is pass or not. And now go to the design and verify your member pass. Now the 6 concrete frames are failing. You can select it and show select it object only. You can see here these members are failing. So it's Yeah, this member is also filling, and these members are filling. So you can go to the envelope option, and after that you can increase the depth of that of these beams also. Then after you can design your structure. So that's it from my side. So if you have any query, if you have any doubt related to designing in the Etabs, in the Statpro, in the, any software, so you can ask me and you can contact me. My contact details are in the description box below. You can contact me anytime. Okay. So if you have any doubt, if you want this just file, you can contact me also. And if you have any query related to designing in the tab, so you can call me and you can message me also. I have put down my contact number and email ID. So thanks for watching this video, and thanks for watching, and don't forget to subscribe and hit the bell icon, and don't forget to hit the like button also. Okay, please share this video. Thanks for watching.